So in the final stretch here, I want to look at a simplified version of an electric motor. So there's definitely a little bit more detail to it, but this is what it looks like stripped down completely. So in the middle here we have, and I'll highlight it with my magic pen, this is our iron core. Okay, so just put that over here in the notes. Okay, soft iron core in the middle. If I'm to follow the current using our conventional flow, so negative to positive, the current's going to go this direction. If we follow it through, so if I follow the circuit, it goes into this half moon. So A and B are not connected, these half moons. So my current, the only way you can get out is to go through this wire here. So it's going up and over my current. So if we use right-hand rule number 2, that would mean I would have to grab from underneath, which means my thumb would be pointing this direction. Sorry, pointing that end to be north, which makes that end south. All right. As I follow the current through the wire, it goes all the way down here, goes underneath, goes behind the iron core, and goes up and over. So that means that it's going in that direction. So at that end as well, if I go to grab it, I'd be grabbing from underneath, and it's also thumb pointing that way, so that's north, and that's south. So the whole iron core, the way it's wrapped, is north and south. And then my current goes through the half moon at B and then returns back to the source. North and south, we have an attraction here. All right, so they want to get as close as they can together. Same thing down here, we have a north and south. So what's happening is momentum is created. All right, so this wants to get as close as it can. So this is really the point where it's closest. So it wants to spin the iron magnet, or the iron core, that way. This one wants to spin this way. Because the iron core is pivoted on a pin, it's free to rotate. So there's stage 1. So iron core becomes magnetized. Okay, so that's stage 1. Now if we move down, I'm going to go up a little bit, and look at stage 2, what has happened. And if you want to just color that in, it should be touching A. You'll notice that up above, the lead from this power source is touching A. Now it becomes switched. So you'll see that this half moon here, where's my magic pen? This half moon is no longer in contact with that power source. It's now in contact with the other moon. So if we follow through our current here, it's now going to go through this direction, and because the moon, they're not connected, it has to exit, and it's going to go up and over. Okay? So if we grab the iron core, our fingertips have to go over top. So now the north and south end have switched. So if you look up above, south-north, it now becomes north-south. Following the current through, so the current goes all the way down here, it's going this direction around, which also supports, then I have to grab it from behind, so north-south. So what happens, the iron core becomes reverse magnetized. All right, poles switch. And what happens was, this was already swinging in this direction from the previous one. Okay, see here we drew that arrow there. It's swinging in a counterclockwise direction. Now, the north and south, because we have like poles side by side all of a sudden, these guys don't like each other, it repels, so it pushes it in that direction. South-south pushes it in this direction. So now we are rotating counterclockwise. All right. So that electric motor is now starting to spin on that spindle, okay? Because we've just changed, we reverse magnetized it, so now they're repelling each other. Moving on to stage 3 then, we know we already have motion in this direction, all right? So I'll just put that in there. What happens now, if I follow my current, I'm not going to go through the whole process again, you'll notice the connector, they've switched back again. All right. So the connectors switch, changing the magnetic poles. All right, so if we follow it through, one last time here, we see that it's going underneath and over top. So if I was to grab it, this end of the iron core has now become north again, and this one, oops, sorry, wrong way. I have to go underneath. My bad. That would become south, and that becomes north. So now there's an attraction, and what it does is it, again, wants to spin this direction. So momentum is maintained by the north and south, or the north and south alternating. Okay? So the flow of electricity changes, causing, oops, I'm skipping words now, changes, causing the poles to switch on the iron core. Allowing for it to spin. So it's encouraging that spinning process, and it's the same thing down here again. Now all of a sudden when you change the connector, this now becomes north, so they repel. This one will become south, and that motion is, again, continued. So in an electric motor, when you're playing with your remote control car, this is what's happening inside in the motor. You push forward, you create current to go through, and inside that electric motor, that soft iron core will spin because of the combination or repetitive repulsion and the repetitive attraction. So it spins, which drives the drive shaft or transmission, which makes it go forward. To go in reverse, you hit backwards, and all you're really doing is you're reversing the flow. Okay? If you reverse the current flow, our diagrams would be the exact opposite. It would spin the other direction, driving the transmission the other direction. So that's how a simplified electric motor works. Okay? It's a combination of traction and repulsion by that iron core switching south and north poles repetitively, spinning that center iron core. All right? I can go through that again in a little bit more detail if you need to. Some of you will be familiar with it from your tech classes. So, last thing I want to talk about is the electric dam, just briefly. So what happens with the electric dam? Well, you have your water, and we'll have the bottom of the water back here, and we're going to have our dam structure. Oops, draw it properly. All right, and what happens so for example, Niagara Falls, the generating station, all right, your generators are at a lower altitude, all right? So let's say that your water level's down here. What happens is they have a water intake right here, for example, enters the tunnel and goes to, we'll call it a turbine, and then returns to the river flow. So we talked about it earlier in the hydraulics unit, that pressure change. All right, we have a change in energy. So the water has energy because it's changing height, and that's your gravitational potential energy. It'll go through the turbine. So that is my turbine. Okay, intake for your supply. That is your return. So what's happening in that turbine? All right, well, this is where my drawings get a little sketchy. Okay, so then the turbine, what does it look like? Well, it looks like a series of propellers. It's like a water wheel. Think of it as a water wheel. Let's see what I can do here. So it has, oh, I'm not even going to try. Here, I'm going to go like this. There'll be one that comes out the back. Okay, so we have propellers. Okay, so the water will spin the generator. So that energy from the water coming down the intake will spin this propeller in one direction or the other. And inside that turbine, you have magnets and a soft iron core. So that soft iron core inside, all right, is coiled with wire. So there's a whole bunch of wire wrapped around. And the exterior shell has a bunch of magnets. This is a very, very crude drawing, but that's the best I can do. All right, so it spins because of the propellers, the water driving it, and what's happening is those magnets are inducing induce electrical current. I don't know why I try with these drawings. All right, so because that casing, okay, this is all inside the turbine. The turbine on the outside has propellers. The water strikes the propeller, spins the turbine. All right, so right here, this is being spun in one direction or the other. The casing, so if we were to look inside this inside casing here, that's what we have here. The outer casing has a series of magnets that's spun, or vice versa. The coil might be on the outside, the magnet in the middle. Okay, it's spun, and what happens is current is then induced from there. So obviously, hopefully I can find a YouTube video that shows it with a lot more detail, maybe something that's nice and animated, but that's basically the principle behind it. The water technically doesn't create the electricity, it transfers its energy from one form to another. So you get the gravitational potential energy of the water to the mechanical energy that spins the turbine, which creates a magnetic field, which then creates current. All right, so it's a series of actions that give you that actual electricity from the dam. So anyway, very, very rough sketch and overview, and I'll see if I can track down a YouTube video that gives you a lot more detail and better pictures, so you can kind of visualize what's going on. That's it. That finishes off the 5th unit, electricity and magnetism. Any questions, anything you want clarified, please don't be afraid to ask, and I'll talk to you tomorrow.